Hey everybody, we're going to start a new chapter. All right, it's actually our last full chapter that we will do. It could be the last chapter for all we know. There might be a little bit after this, but chapter 5. All right, and it's going to be we're going to talk about logs. And so first part of this is going to be review from some algebra 2 and pre-cal stuff with natural log. All right, and then we'll talk about at the end of this lesson. We'll talk about the derivative, how to find the derivative of a natural log. All right, and then we will next lesson, which is the same section, we'll solve like some equations using logs, and then 5.2 will be taking the integrals of logs. All right, and then we'll have a little quiz on that. All right, and this will take a little bit. Quiz won't be anytime soon. All right, and this is you once again. You're still going to be able to use your formula sheet for any quiz, homework assignment, anything you need moving forward. You're allowed to use that. All right. so just review. First of all, with the graph of y equals ln x, natural log of x. Remember, the base of a natural log is e. All right. So in case you forget, there is a vertical asymptote at x equals 0. And to make it nice and easy for you guys, I'm only going to make you graph 1 point, and that is going to be at 1, 0. And it looks something like that. All right, that is the graph of y equals natural log of x. All right, the domain of this would be from whatever the vertical asymptote, in this case, it is 0, and it's going to infinity, and the range is negative infinity to infinity. All right, this is a continuous function. All right, it's continuous. It is increasing. It is 1 to 1, and it is also concave what? This is concave down. All right, it is concave down. All right, so just a couple basic graphs here. Keep it real simple. Just a couple of transformations that are happening. Anytime you have a number being plus or minus inside of here, inside the x, all right, this is going to move it left or right. You just set this equal to 0. So we're just going to move this to the right 1. So instead of being at 1, 0, we're going to be at 2, 0. Instead of the vertical asymptote being at 0, it's going to be at 1. And it looks like that. All right, and there's that graph. Here we also have a 1, but notice how it's not in parentheses. So this is not a shift to the left or right. This is a shift up 1. So whatever, if this was a -1, we would go down 1. It's not in the parentheses. So vertical asymptote stays at 0. Instead of being at 1, 0, we're going to move it up 1. That 1 point is going to be at 1, 1. All right. If you have a negative out in front, that is going to be a vertical flip. All right. It's going to be a vertical flip. We still have a vertical asymptote at 0. All right. The point, vertical flip means you change the y-axis, the y coordinate. So you're at 1, 0. It's going to stay at 1, 0, but instead of going like this, it's going to go like that. All right. Now, one that's not here, the only type of transformation would be if it was y equals the natural log of like negative x. What happens there is that is a horizontal flip. Instead of being at 1, 0, it's at negative 1, 0, and it looks like that. All right, that is a horizontal flip. Those are the 4 types of transformations that you could have. All right, now some properties of logs, which most of this should be revealed. All right, so if you have the natural log of 2 things being multiplied together, natural log of a times b, you can split it up by addition, the natural log of a plus the natural log of b. Remember, this is expanding. So for example, natural log of xy is just the same thing as the natural log of x plus the natural log of y. If you're dividing 2 things, you could be split up by subtraction. So natural log of a divided by b is the same thing as natural log of a minus the natural log of b. So the natural log of 40 over 7 is the same thing as the natural log of 40 minus the natural log of 7. If you have an exponent, that exponent can be brought to the front. So the natural log of a to the b is the same thing as b times the natural log of a. So for example, the natural log of x cubed, the 3 comes out front, and it's just 3 times the natural log of x. All right, so multiplication, addition, division, subtraction. exponents go out front. All right, a couple other things to remember. The natural log of 1 is always 0. All right, the natural log of 1 is 0, and the natural log of e is always 1. All right, the natural log of 1 is 0, natural log of e is 1. All right, a raised to the log base a of b. Okay, now notice how this base here is the same as that base here. So if that's ever the case, and you raise to a log of that, it's always this answer. That's why the answer is b. So for this problem, log, it's 3 raised to the log base 3 of 21. These are the same 3 and 3, so the answer is just 21. All right. This one here. There is no base here, but what's the base when it's natural log? The base is e. So since the bases are the same, the answer is just x squared. All right, so whatever that is right there. All right, now when we are evaluating these, all right, it says, remember, logs are exponents. We can rewrite this as an exponential, okay? So if I'm trying to figure out what is log base 3 of 9, remember that's how we say it, log base 3 of 9, what does that equal to? That's what I'm looking for, what x is here. Well, this means 3 to what power equals 9. Some of you might have heard from your pre-calc teacher, left, right, left, 3 to the right over here equals that. 3 to what power equals 9. So the answer is 2. All right, remember, if there is no, when you have a log, if there's nothing written, no base, we assume it's 10. All right, so 10 to what power equals 1,000. So the answer is 3. If it's natural log, what's the base with e? With natural log, sorry, the base is e, right? Remember, this is base e. So e to what power equals the square root of e? Well, remember, the square root of e is e to the 1/2. So if e to the x equals e to the 1/2, that means x is 1/2. And here, what's the natural log of e? The natural log of e is always 1. All right, and because e to what power equals e first. All right, that's why it is. But you should just kind of memorize natural log of e is always 1. All right, so we are going to now do expanding logarithmic functions. All right, expressions, sorry. So to do expanding, that means that we are going to start with one natural log and we are going to have several. Okay, now the easiest way to do this, all right, when I'm expanding, anything that's up top is going to get a positive. Anything on the bottom gets a negative. Anything with an exponent goes up front. So we have two numbers here. It should be 2 natural logs. So this could be a natural log of 10 minus the natural log of 9. There's your answer. All right. Here, I have 3 and I have an x squared. All right. They're being multiplied. 2 different terms. So it's 2 different natural logs. All right. There's nothing on the bottom here. So there's no negatives. So it'll be all positive. So I have the natural log of 3 plus the natural log of x squared, but the exponent is just going to go in front. So it's 2 ln x. All right. For 3, this is the same thing as 3x plus 2 to the 1/2. Now, even though 3x plus 2, that's 2 different terms, that's 2 different natural logs. It's not. Okay? It's something's in parentheses, it's all one thing. It just gets one natural log. Here, the 3 and the x squared, it's not in parentheses. This is 3 times x squared. All right? So the only thing we need to do here is move this to the front. So the answer is 1/2 natural log of 3x plus 2. Nothing else you can do. Okay. In this problem, I have 1, 2, 3 different things. So that's 3 different natural logs. Anything on top gets a positive. Anything on the bottom gets a negative. Exponents go out front. So I get 2 from this 2 here goes up front. Natural log of x squared plus 3. Now I go to the bottom. Minus. Why is it minus? Because it's on the bottom. Exponent goes up in front. 3 natural log of x. Minus because it's on the bottom. This is the square root, so it's the 1/2. 1/2 natural log x squared plus 1. All right, so that's expanding. All right, so now we are going to condense. So we have all these natural logs. We're going to make them into one. All right, these are pretty easy. All right, so what we're going to do is I'm going to make one big natural log thing here. And as soon as I see a negative, it means I know there's some fraction of some sort. All right, anything that has a positive is going to go on the top, and then negative is going to go on the bottom. Any number up front means it's really an exponent. So this 2 is an exponent to x plus 3. So this is x plus 3 squared. And this is y cubed. Remember, it's multiplication. All right, you don't put a plus sign in between them. The plus just means it's on top. Negative means it's on the bottom. The 1/2 means it's the square root. So it's the square root of 2x plus 1. All right, same thing here. I see a negative, so I know I have a fraction. If I didn't have a negative, it means it was just no fraction. Everything's just on top. So this is 2 to the 4th. What's 2 to the 4th? Isn't that just 16? This is negative and negative, so it's both on the bottom. Third, is it really the cube root, right? So it's the cube root of x. Why is it on the bottom? Because it's negative. And then 2 times x, that 2 is really just an exponent that's squared. So 16 over the cube root of x times x plus 3 squared. All right. So hopefully this was, you've seen this before. There'll be a couple practice on the homework, but hopefully you've seen that before. So refresh. Once you do a couple again, it'll be like, oh yeah, this isn't bad at all. All right. Which leads us down to finding the derivative of a natural log. All right. So we're back to a couple of derivatives. We've never done derivative of natural log before. Okay. Now, this formula right here, this is on your formula sheet. If you look on the left-hand side, it says how to find the derivative of natural log of u. It is du over u. Okay. Which basically means it is the derivative of ln u is the derivative of the inside. So we're taking the derivative of the inside all over the inside. So basically you're taking the derivative of whatever comes after the natural log over what comes after the natural log. All right. So natural log of 2x. So the derivative of the inside over the inside. The inside is 2x. That's what comes after natural log. What's the derivative of 2x? 2 over what is the inside? Well, that's 2x. Cancels. 1 over x is your answer. So the derivative of the natural log of 2x is 1 over x. All right. Little hint here. This could be the natural log of any number x. It doesn't make a difference. It will always be 1 over x. If it was the natural log of 1,000,000x, the derivative of 1,000,000x is 1,000,000 over 1,000,000x. The millions would cancel. It would be 1 over x. All right. So natural log of 3x squared plus 2. All right. So it's the derivative of the inside over the inside. So what is the derivative of the inside? All right, well, the derivative of the inside is 3x squared is 6x. 2 is 0, so it's just 6x over the inside. So it's 3x squared plus 2. So there's your derivative. 6x over 3x squared plus 2. The derivative of the inside over the inside. The nice thing is you don't have to memorize it because you can look at your formula sheet and you're going to see du over u. All right. And when you see u here is the inside of whatever comes after the natural log. So you're taking the derivative of that over whatever that is. Okay. Now, in this natural log, we have x cubed times. And it looks like, oh, this is going to be a pain in the butt. Well, not really, because what we can do is, since all of this is on the inside of a natural log, we can expand it first. All right. So we can expand it and we can make it into 2 natural logs. We can make this 3 natural log x plus the natural log of 5x plus 1. All right. So now I expand it. Now I just take the derivative of the 2 separate things. So it's 3 times the derivative of natural log of x. That's the derivative of the inside, which is 1, over the inside, which is x. So that's 3 over x. Remember, anything x is just 1 over x. Here, plus the derivative of the inside, the derivative of 5x plus 1 is 5 over 5x plus 1. So this derivative is 3 over x plus 5 over 5x plus 1, and you are going to leave it like that. All right. 4. All right, we are going, what rule do you think we're going to have to do first? Now, there's two things. We have two things with x's. So what rule are we going to have to use here? We're going to use the product rule. All right. Now, the reason we don't use product rule here is because it was natural log. All of this was after natural log. This x squared is not on the inside here. If it was, then we could do what we did up here. So remember, the product rule, in case you forget, is the first times the derivative of the second plus the second times the derivative of the first. Okay, so the first is just x squared times the derivative natural log of 5x. Well, it's 5 over 5x, which is just 1 over x, plus the second, which is the natural log of 5x, times the derivative of the first, which is 2x. All right, x squared over x, those x's cancel, make this x plus 2x natural log 5x. There's your answer. All right. 5. What rule do you think we're going to have to use first? Well, it's a quotient rule. All right, natural log of x squared. Now, if it was the natural log of, and in parentheses, you had x squared over 5x plus 2, then we could expand it first. All right, but we don't. It's just natural log of x squared over just 5x plus 2, not the natural log of 5x plus 2. So the quotient rule, in case you forget, is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so the bottom is 5x plus 2 times the derivative of the top. All right, so what is the inside here is x squared. What's the derivative of x squared? It's 2x over x squared. All right, it's 2x over x squared minus the top, which is the natural log of x squared, times the derivative of the bottom, which is 5x plus 2, which is 5, all over the bottom square. All right. So the only thing here is, let me get a different color. So if I reduce this, that x is gone. So it's 2 over x. All right. We can't really have a complex fraction. So the best thing to do, easiest thing, just multiply everything by whatever that is. So that cancels with that. So our final answer is 2 times 5x plus 2. Then you do x times that. So it's negative 5x natural log of x squared. And then on the bottom, x times 5x plus 2 squared. If you left it without reducing the complex fraction, not the worst thing in the world. But to be completely correct, you should get rid of that complex fraction, which is just to multiply by whatever that denominator is by every term. All right. All right. Last one. All right. Just kind of box this out of here. All right. So for this one, what do you think we should do first? All right. Since all of this is after natural log, what can we do? Well, we can expand it. All right. So anything that's up top gets a positive. So it's 2L and x plus 4 natural log of 5x plus 3 minus 1/2 natural log of x minus 2. All right, so now we just take the derivative of each of those. So it's 2 times, what's the derivative of natural log of x? That's 1 over x. We'll simplify that in a second. This is 4 times the derivative of the inside, which is 5x plus 3, which is the derivative of that is 5 over 5x plus 3, minus 1/2 times the derivative of the inside. Derivative of the inside is just 1 over x minus 2. So my final answer is 2 over x plus 20x over 5x plus 3 minus 1 over 2 times x minus 2. If you wrote 2x minus 4, that's also okay. And there's your final answer. All right, so to find the derivative of a natural log, it's the derivative inside over the inside. All right, do some more practice with this on your assignment today, and then we'll also do more stuff tomorrow with natural log. We will do logarithmic differentiation and implicit differentiation with logs. Okay, and then the next lesson after that will be integrals with natural logs and some more practice on that. So you're, like I said, another week or so before you think about having a quiz. If you have any questions, please reach out. Let me know. All right, take care. This will be our last lesson for this week. So hope you guys have a great rest of the week and a good weekend. And I'll be talking to you guys next week. Okay, bye.